Jim here, little shop on the prairie. So we're going to do something different this time. I'm going to work with my homemade CNC machine, which I built on the Shopsmith. I was doing some routing, and I was doing some molding, small molding, and this hole causing me difficulties. The piece was so small it was drooping as I was cutting in and catching on the other edge as I was trying to go across. Kind of a pain. It didn't cause me any problems, but I didn't like it. And so I'm going to do an insert, a zero clearance insert for the router insert. And I was using SketchUp and Sketchucam to draw up parts for the CNC machine. And I found a gentleman had drawn up a part to fit right in here, a 3D drawing to fit right back in here to fill this whole hole. And that was as far as he went with the 3D warehouse, which was kind of neat. I thought, okay, well, I'm going to go ahead and take that, convert it to 2D, and then I can cut it out on the CNC machine. Well, as I thought about it, it was going to be, I would have to set everything up first for the zero clearance, and use these two screws to help hold it in place with a washer maybe. Then if I wanted to change bits, I would have to get underneath the table and unbolt this. And I thought, shoot, that's going to be too much work. And I don't like to do work anymore. So I'm going to go ahead and cut out the entire insert and then make my own capability right here for zero clearance. I know some of you guys, you'll know, you can cut this out on the saw with a bandsaw to cut that edge there, and a drill, you know, really fast. They're not hard to make. Use a 1/2 inch MDF. And on the back here you got to route a little bit in order for it to fit in. But that's okay. It's not hard to do. But what I want is like the more expensive router tables, where the insert here, they have a tool and they twist it in, twist it, pull it out, so you can quickly change that insert. And that's my goal, is to make one of these for the Shopsmith to do the same thing. So I started drawing it all up on a new CAM software for the CNC called Native Cam, that's part of Linux CNC, which is the software I use to drive my CNC machine. The CNC machine, by the way, it's right here, and this guy, I built it with the Shopsmith. I bought a book from Barnes & Noble on how to build a CNC. And so we'll get to watch that thing in actual order or working. It might be fun. So now here's the hold on a minute. I should have had this more prepared, but this is the book I used to build it, and you'll see that it looks just like it. It had its downfalls. I replaced the lead screws with 5-start, 10 thread per inch, because I wanted it to go faster. The book called for regular 1/2 inch or 3/4 inch threaded rod, 13 turns per inch, and it just was too slow for me. And I got a couple other issues that maybe I'll show you. I'm going to have to cut some more parts out for the CNC. So the CNC machine will make parts for itself. But anyway, enough of the rambling. Next video I'll show you, or the next section I'll show you Linux CNC and show you what I've got drawn up. Thanks for watching. Alright, so this will be a first on me trying to do what I do with the software. This is my Linux box, and we're going to go ahead and start up Linux CNC so you can see what I'm talking about. And I use the CAM software now that's part of Linux CNC, so I can do everything on one machine. So let me do this really quick because we're not going to run anything. That left side is what runs the code to cut, but this is where I design my work. This is the screen that I use, and we'll go ahead and open up the project. Shopsmith router insert. We'll open that up. Alright, so this little box is the workpiece. We're going to turn that off. I don't need to see that anymore, but I use that to orient where on the piece of wood that I'm using I can cut and can't cut. So as you can see, I've got it drawn out up here. This is a look at it straight on, how it's going to look. And the little lines in between are the cut paths that it's going to do to move through the part. And here's right here, I'm not sure, oh yeah, maybe we can see this. These are the little tabs I'm going to cut in on the insert for me to be able to drop the piece in. So when I cut the insert part, it'll be a circle with tabs on either end like that, that'll fit into those openings. So, and then I'll be able to twist it to lock it in place. That's the plan. Whether it's going to work, I don't know yet. But this hole, let's see if we're going to be able to see this or not. Yeah, maybe. Yeah, we should. As you can see, this is the first part of the hole. It's on the inside edge, and then this is the outer edge. So this is recessed into the piece of wood. I'm not sure if this is going to show up really well on the camera, but that's where these two holes are. So the new insert's going to be a little bit smaller than the Shopsmith opening that's in there now when it's fully open, but that doesn't matter, because if I'm going to have a bit that big, I'm just not going to use this insert. I'll use the stock insert. So anywho, thanks for watching on that. Next we'll probably be able to watch the CNC machine cut it out and then see the part. So this over here is called Native Cam, and you have all these things that you can add with it. You can add a circle, you can add a rectangle, all this stuff for machining work. I don't want to go into it, but that's how you do it. You set up your dimensions right here, your X and your Y, for whatever you want it to cut out, and then you can watch it on the screen here and move it around till it's right where you want it. So I like it because it's all built in. I don't have to do a thing. Once I get it drawn out, I could turn right around and cut it out at the same time. So next episode coming up, we'll have the machine running. See ya. So here's what it takes. I already cut, and if you notice up here, there's quite a few cuts on this radius till I could get the radius right. And after I learned to be better at machining, I probably wouldn't have to make so many test runs. But if you notice over on this side here, my cut was off on the length, and I know that was it because I had to change the radius. So when I changed the radius cut, it changed the end cut. So we have to adjust that. And then when I did this, the center hole here, because of all that, was off, so I have to move that. The front holes were good, so in order to do that, there's a lot of calculations and figuring out. So how to use that. Calipers to figure out the distance that I need to make adjustment. And then inches to decimal chart, because the machine does everything in decimals. And then on the machine, let's see if I can do this without getting too flaky. I use a calculator down there to calculate the changes that I do over here in my XY coordinates to move everything and make it come out right. So yeah, it'll look like, if I didn't show you this part, it would look like, oh God, you just made the part and went. No, not really. There is a little bit of work ahead to make sure that it's right. And next now what I have to do is Linux CNC and Native Cam do not do tabbing. What tabbing is, let's see if I can get around here and point where we're at. I had put a tab in by changing from a rectangular shape to polylines, and I had it stop at a point here and then start at a point here, so there was two separate lines and it wouldn't cut here, so that when it cuts all the way through, this piece doesn't move. That's called tabbing. Well, I put the tabs in. I didn't take into consideration the thickness of the bit, the end mill that I was using, so there's no tab there, even though it lifted and went over and back down. But because of the thickness of the bit, it ended up cutting it out anyway. So I had to increase that opening. I went to a 1/2 inch because I have an 1/8 inch bit, and that should leave a gap or a non-cut part right here and a non-cut part here. So when it gets all the way through the part, this can't move. Right now I didn't go all the way down through the board, so everything stayed in place. And the reason I did that is I wanted to be able to do like so, and look and see, match my part up, make sure that everything was good. This hole was right on. I did get that part, and this part is not that far off. So coming along, I guess you won't be able to see from there, but I did get the offset here proper, here and here, because it's wider here and thinner here. And that's just because when you're in router mode, the way that the headstock is and where the router actually comes up through the bottom, it's off center from this. I don't know why. The only thing I'm thinking of is so that you can use the shaper fence. But I don't know why. And, oh yeah, I didn't cut these in. I need to do that here and here. But I don't know if I can thread it. I got to think about that for a bit. If I can't thread it, I'll drill holes into here for a dowel pin. So I can stick a dowel pin in instead of the metal inserts that thread into there. We'll see. That's more work, but that's okay. Once I get it done, as you can tell, maybe, I'll be able to make a bunch of these. I'll lay boards out, and I should be able to make like 3 out of this just by doing offsets. When I set it up, just turn it on, let it go, come back in an hour or so, and have 3 zero clearance inserts made that'll fit perfect every time. Thanks for watching, you guys.